Hey, yeah, let's cover compound interest. So we've already covered simple interest, and a lot of these the letters and the references. Compound interest is when you have money invested into an account only once, just like simple interest, but simple interest will say the word simple interest. This one you're going to need to know that it is compound interest only because the money is being put into the account once or moved into an account once and not continually invested in, not continually putting money in or pulling money out or simple interest or anything like that. Okay. It's going to have compound interest, of course, but it will also have the money's only invested once. So you're going to have to read into that. All right. The compound interest formula is this. A is still the ending balance after 2 years. This is still the initial amount, starting amount, principal. Rate is still the APR or the interest rate in decimal form. T is still the time in years. N is the only thing new. And it's not even really new. We've done something like this when exponential functions. All right. So N has to do with the number of compounding periods in a year. How often does it happen in a year? So if it's done annually, that's once a year. So N would be equal to 1. If it's semi-annually, this is in your homework, N is 2. It happens twice a year. Quarterly happens 4 times a year. N is 4. Monthly happens 12. Weekly happens 52. And daily happens 365 times a year. How much interest accrued? This is exactly the same as the simple interest formula. I did this on purpose so that you know it's the ending balance minus the beginning amount that's invested. Okay. Let's start with an example. I'm going to do this one, and then I'm going to want you to do the next one. Sorry. So you deposit $300 into an account earning 5% interest compounded annually. You're putting $300 in once and earning 5%. And it's compounding annually. So this means that my N is going to be equal to 1. This is my P, and my interest rate is 0.05. I go ahead and prep that, and my years are going to be 10. How much will you have in the account in 10 years? So I can just plug and chug. The amount I'm going to have at the end is, I'm going to have 300, 1 plus 0.05 divided by 1, raised to the 1 times 10. Now, I'm going to show you how to put this in your calculator if you're not the 2 students who have the XAs. You know to put a multiplication sign here. You're going to put in 300. You're going to do it all at once. Parenthesis 1 plus 0.05 divided by 1, close, caret, open, 1 times 10, close, equal. And that will give you the ending amount. All right. Give me a second. All right. So 488.67 dollars will be in the account in 10 years. Here's the answer. How much interest accrued? That's the ending amount minus the starting amount. So interest 488.67 minus 300. Make sure you clear your calculators, otherwise it will be wrong. And it's $188.67 in interest accrued. All right. Next one I want you to do. Actually, yeah. How much will $1,000 deposited in an account earning 7% interest compounded annually be worth in 20 years? And how much interest accrued? Pause the video, do this on yourself. When you come back, I'm going to go through it pretty fast because you can always slow me down and because I've got a lot to cover today. All right, so A is equal 1,000, 1 plus 0.07 over 1 raised to the 1 times 20. Putting it in a calculator is 1,000, open, 1 plus 0.07 divided by 1, close, caret, open, 1 times 20, close, equals. And I get 3869.68. Will be in the account in 20 years. The interest is the ending amount for your calculators minus the initial investment. And interest accrued. Okay. I'm going to do the next one, then I want you to do one. You deposit $9,400 in an account earning 4% interest compounded semi-annually. This means N is equal to 2. The percent is 0.04, and this is my P. How much will you have in the account in 5 years? So we have $9,400 invested one time. 1 plus 0.04 divided by 2 raised to the 2 times 5. 9,400, open, 1 plus 0.04 divided by 2, close, caret, open, 2 times 5, close, equal. And I got $11,458.55. Will be in the account in 5 years. Interest accrued is just the amount at the end minus the 9,400 at the beginning. Make sure and clear your calculators. And I got 2058.55. Make sure and use your dollar sign. You have to have your units in interest accrued. All right, pause the video, do the next one yourself, and then come back. It says you deposit $2,100 in an account earning 2.5% interest compounded semi-annually. Again, N is 2. How much will you have in your account in 7 years? I'm going to put this up here. Pause the video so you can see compared to how I'm doing it, and make sure you get the setup right. Okay. All right. Pause your video. Moving on. All right. So this is my P. This is my 0.025, and this is N is equal to 2. 7 years. So A is equal to 2,100. 1 plus 0.025 over 2 raised to the 2 times 7. 2,100 open. 1 plus 0.025 divided by 2 close, caret, open. 2 times 7 close equals. And I got 2498.90. Was in the account in 7 years. Interest accrued, the ending amount minus the beginning amount. So $398.90 in interest accrued. All right, and we had already started this one. I was hurting too bad, so I had to stop, so bear with me. You deposit $4,000 in an account earning 8% interest compounded monthly. These are exactly the same. It's just your monthly is N is 12. Okay. I'm going to go through and knock out just the numbers real quick so that you can go through and do these yourself. Same setup. I just want to make sure you have the practice you need. 1 plus 0.08 divided by 12, close, open. 12 times 10, close equals. So 8878.56 should be this one. And then minus 4,000 should be 4,878.56 for your interest. Okay. The next one, compounded monthly, same thing. In case you decide to do this, it's 200, 1 plus 0.052 over 12 raised to the 12 times 15. And I got 15 years, 5.2% interest. Let me double check my work. 200, 1 plus 0.052, 12, caret 12 times 15 close equals, yeah, 435.56. And then 435, well, it's 235.56. You'll still have to write sentences. I'm trying to get through to the next part. You deposit 2,000 in account earning 3% interest compounded monthly. How much money will you have in 20 years? Pause the video, do this one yourself. I'm just going to go through and do it really fast. $2,000, open, 1 plus 0.03 divided by 12, close, caret, open, 12 times 20, close, equals 3641.51. The interest earned was 1641.51. Deposit 10,000 in account earning 4% compounded monthly. Okay, again, same thing. N is 12. A is equal to 10,000. 1 plus 0.04 over 12 raised to the 12 times 25. 1 plus 0.04 divided by 12, close, caret, open, 12 times 25, close, equals. Your answer is 27137.65, which makes your interest 17137.65. Same thing here. Our N is 4 because it's quarterly. Now you deposit 5,300 in an account earning 5% interest. 0.05 divided by 4 raised to the 4 times 6. And the amount in the end is $7,140.96. And then your interest accrued is the difference between 7,140.96 minus 5,300. And that's 1,840.96. You deposit, again, 7,000, interest 3.5%, compounded quarterly. Let's just get you a number. Pause the video, make sure you can do it. 0.035. These are only for those folks who are actually going to continue doing the work to practice. 7,000 open, 1 plus 0.035 divided by 4, close, caret, open, 4 times 8, close, equals. So $9,250.64. The interest accrued is 2250.64. The 9250 minus the 7,000. Oh, it looks like that already jumped to 1. So I'm going to see if I can cover this up and, oh yeah, I have blank paper. All right. So I'm going to go up here and finish this last one for you so you have it as well. Excuse the number. It was just a doctor I had to see. So A is equal to 3,000. 1 plus 0.08 divided by 4 raised to the 4 times 10. So your amount you have at the end is 6624.12. And the amount of interest you accrued is 3624.12. All right, now we're down to something that was different, which is why I did this one. This one, they want to know how much you deposit. They don't want to know how much you have in the end. They want to know P. R over N to the NT. So we're looking for P. You can do this as however you want to do it. The most important thing is let's get you set up. You want to have 4,000 in the end. We're looking for P. The rate is 3%. It's compounding monthly for how many years? 10 years. So what I typically do is the right side, pause, put in 4,000 divided by second answer equals. And this is what I can do with this calculator. And it's what you'll be able to do with your calculator unless you have the TI-30XA. All right. So I'm going to just, or you could just go 4,000 divided by, and then all of it. You could do that too, however you wish to do it. So parenthesis 1 plus 0.03 divided by 12, close, caret, open, 12 times 10, close, equals, pause. All right, so this is what I have. I'm not writing this down. This is just the gibberish from the right side. Now I pause the video and I just type in 4,000, not video, I pause myself, and divided by second answer equals. And you need to pause it. You need to deposit $2,964.38 in order to have the 4,000 in 10 years. Okay. The interest that accrued is just the subtraction of the 4,000 minus the beginning amount. Clear your calculator. 4,000 minus 2,964.38 and $1,035.62 in interest accrued. Okay. All right. Now, this next one's for you to do. Same exact concept. How much would you need to deposit? We're looking for P in an account now in order to have 2,500 as your A in the account in 5 years. Assume the account earns 2.5% interest. I'm setting it up. Compounded monthly, so N is 12. So we want to have 2,500. Go ahead and pause the video and do this yourself. 0.25 over 12 raised to the 12 times 5 years. Put this in your calculator. Again, I'm just going to do the right side. Parenthesis 1 plus 0.025 divided by 12, close, caret, open, 12 times 5, close, equals, pause, and then 2,500 divided by second answer equals. So you need to deposit $2,206.53. Make sure you round to the hundredths place always. Lastly, how much interest accrued? Interest is just your ending amount minus your beginning amount. Again, clear your calculator. 2,500 minus 2,206.53. And I got $293.47 in interest accrued. All right. How much would you need to deposit? That's the exact same kind. So I'm going to just knock this out real quick. 6,000. Pause the video and attempt this one yourself. Come back, see how you did. 6,000 equals P 1 plus 0.06 compounded monthly for 8 years. Parenthesis 1 plus 0.06 divided by 12. Close, caret, open, 12 times 8, close, equal, pause, and then 6,000 divided by second answer equals. And I got 3,717.14. That's how much needs to be deposited. And then 6,000 minus 3717.14. And you need $2,282.86 accrued. Okay, in interest. How much do you deposit? Same question. So pause the video and attempt this next one yourself, and then come back and see what your answers were. So 20,000 equals, sorry, 1 plus 0.07 quarterly for 10 years. Parenthesis 1 plus 0.07 divided by 4. Close, caret, open, 4 times 10, close equals pause. 20,000 divided by second answer equals. So you need to deposit $9,992.02 in order to have 20,000 in 10 years. Money typically doubles every 2 years if you have a good interest rate, which is usually at least a 6.5 to 7. All right, and then interest accrued, you just subtract the 20,000 and the 999. So let's go 20,000 minus 9992.02. So you earned $10,007.98 in interest. All right, I'm going to skip because I'm going to just continuously how much you need to deposit, same thing. Find the value of the investment in. Okay, then it's got 3. Okay, all right, so let's go jump to 23. This is just going to be some practice with the percentages. So it says you deposit 23,000. That's my P. Find the value of the investment in 10 years in the same count, 7% compounded annually. So 0.07 divided by 1 raised to the 1 times 10 years. 23,000, parenthesis 1 plus 0.07 divided by 1, close, caret, open, 1 times 10, close equals. So you will have $45,244.48 with this method. If you do 7% simple interest, what does that look like? Well, that's A is equal to P 1 plus RT, different formula. A is equal to 23,000. 1 plus the rate is 0.07 and the time is 10 years. I don't need all those parentheses, but that's okay. 23,000 times 1 plus 0.07 times 10 close equals, and you'll have $39,100. And then it says, what is the difference? Well, you subtract them. 45,244.48 minus the 39,100, and the difference is $6,144.48. Shows you that compound interest is substantially better than simple interest because over 10 years, look, you got a $6,000 more with compounded versus simple. No one uses simple. All right, pause the video and do this next one yourself, and then come back. You're investing 4,000, 0.05 annually for 10 years. So after 10 years, you're going to have $6,515.58. Notice it didn't double. You didn't get 8,000 because it's only 5%. All right, now we're going to do 5% simple interest. A is equal to 4,000. 1 plus the rate is 0.05 for 10 years. And so you have $6,000. What's the difference? $515.58. You just subtract the two. All right, that's the end of this lecture. I'm going to come back and do APY, which will be next.